where I have another mass flow rate in order to create an unbalance in the power, because this power is proportional with m dot, and this power is proportional with a mass flow rate that is much higher than m dot. And you see, like this, you create an unbalance between what is driving and what is driven. And we can readily see now that how higher this m dot here compared to this one, how lower will be this value. And that will be the way to create this decrease in PT4, TT4 by unbalancing the power that is driving the turbine compared to the power that is produced by the turbine compared to the power that is used by the compressor. And you see that we are creating this unbalance with what we call a double flow engine. We have created an engine where we have a flow separation, you see? And we can call these flows different ways. You can say that the flow here is hot because this flow is going into the combustion chamber. We can say that this flow is also the central flow because it's in the middle of the engine. We call sometimes this part of the engine the core, that means the central part, whereas the flow outside is cold, let's say, because it's not going into the combustion chamber. We also call the flow here the primary flow, because this is what's creating everything. This is what is the origin of the engine. Whereas this flow, we will call that the secondary flow. You see that in my turbojet here, m dot s was equal to 0. Okay? And we can say, in fact, that the core of the engine, it is originally my turbojet. You can imagine the situation like you take the turbojet and you put here in front, around the compressor that I had here, and this part of the compressor is also part of the turbojet, you put an external part. And this is delivering the secondary mass flow rate. Without this, but with this included, with this part included, you have your turbojet of before. Okay? And we will introduce a parameter that is looking like essential in the objective we have. This is the ratio of m dot secondary divided by m dot primary. This is 0 for a turbojet, not 0 for the double flow engine. This is what I will call the bypass ratio. It's a ratio, and it's bypassing the core of the engine. You have seen that I have not yet used the term turbofan. I will use this term turbofan a bit later on, because we are, let's say, not yet able to explain how or why we use this term turbofan. It's better to speak here about a double flow engine than to speak about a turbofan. But the situation is not as simple as what we have represented here. Because I have created an unbalance. But the turbine here was driving only this part, including the small part here. This turbine is not able to drive this part here. In order to drive the external part, you need to add a new turbine here. Okay? And this is this new turbine that will give you this decrease in temperature and in pressure at the entrance of the nozzle. So when we say that the turbojet is the core of the engine, it's not exactly true. It is the same compressor coming from here. It is the same combustion chamber. It is the same part of the turbine at the beginning, but then from there it's not the same engine anymore. Okay? What you need to do when comparing, when trying to understand a turbofan, what you need to say is that for the turbojet compared to the turbofan, I've not yet explained the turbofan, you need to say that the primary flow here is equal to the m dot of the turbojet. You need to say that the central compressor is the same in the two cases. Okay? You need to say that the TIT is the same. And if you say that the TIT is the same with this, you can also say that the fuel flow is the same. So keep that in your mind. We are trying to develop this double flow engine with a constant fuel flow. The fuel flow with the engine that I have discussed 1 hour ago and the new engine that I have created with this external compressor in red here, so starting from there, externally, has the same fuel flow than what I had before with the turbojet. Very, very important, same fuel flow. And same fuel flow, it means also that the section 2 is the same for the two engines. That the section 3 is the same for the two engines. That the section 1 here is the same for the two engines. This section was the section 4 of before. I will not write that anymore 4 because 4, this is now this section, I will call that 3.5. And this 3.5 is the section 4 of before, of the turbojet. Okay? But you see that it's more complicated, because I'm introducing new sections. And one new section I will have, this is this one, that I will call the section 1.5. This is the section at which I separate the secondary flow from the primary flow. Okay? You see also that I don't have anymore the same intake. The intake is much larger because the intake is not anymore entering into the compressor. The intake is entering into the large first compressor I have put here. So the intake that was around a compressor face like this is now around a compressor face like this. I need to be very careful with this intake. This intake is very big. So the size of this intake, I need to be very careful with that. You need to keep that in your mind. And you see also that I have another parameter that I have introduced. I will clean a bit the board, otherwise it's difficult to continue explaining the things. So I have also introduced another new parameter into the problem. Look at the cycle that I have drawn. I have said I'm starting from my compressor of before. Okay? This is the section 1, this is the section 2. The same as before, where I have m dot p passing equal to m dot turbojet. And I'm putting an external flow rate here around. An external flow rate here around. It is the same here. You understand in a minute why I'm not drawing the lower part. This is the new section 1.5 with m dot secondary. But there is another new parameter that I have introduced. I could also, with the same m dot secondary, I could also make this, I'm exaggerating maybe, I can also make this external part longer. So the point 1.5 here. What is changing? The pressure ratio here and the pressure ratio there is different. You see that I can reach the same PT2 with a small first compressor that is going up to there and a big second compressor, or I can reach the same PT2 with a first big compressor and a second that is much smaller. And you see that the pressure ratio that I had introduced before must be written as the product of two pressure ratios. You reach the same value, let's say, as before, but you can reach this with a small, large, or a large, small, or medium, medium. And this is what we will call the low pressure compressor. This is the red one. This is the low pressure compressor. And this is the high pressure compressor here, which is the second part, let's say, of the compressor. And so you see that you have not only introduced one new parameter compared to PC and the TIT that I was using before, so first and second design parameter, I have introduced a fourth design parameter. So by splitting my flow like this, I have switched my design space from a design space with two design variables to a design space with 1, 2, 3, 4. Okay? You could say me, no, 5. No, this one is just the second divided by the fourth. So this is not a fifth parameter. And so you see that I have multiplied by 2 the number of design parameters. This is of course always good because it's giving you more freedom in the optimization,